All right, good day and welcome. My name is Nathaniel Skidmore, and today we're going to be looking at a lesson focusing on evidences of a chemical reaction. This lesson will follow along with Alabama Course of Study Standard number 5 to observe and analyze characteristic properties of substances, things like odor, density, solubility, flammability, melting point, and boiling point before and after the substances combine to determine if a chemical reaction has occurred. Now, we're going to be doing this in a number of different ways, and while we're doing this, we're going to try to address all 5 of the E's associated with science learning. Those are engage, explore, explain, elaborate, and evaluate. And we will also try to look and see how we're going to apply higher level Bloom's taxonomy learning levels. Things like evaluating, things like creating. All right, with that groundwork laid out, we're going to begin our lesson with an entry ticket activity to try to get our brains, thinking about science and focusing on science. And how we're going to do that, and also a good way to introduce what we're going to be looking at today, is we're going to try to write down 3 different ways that we can tell if a reaction is a chemical reaction. And that goes along right alongside standard number 5. So you could just pick any 3 of those examples written in standard 5, or you could try to think of a different one. And what this does is it's a good way to get students, thinking about science and being like, okay, we're looking at chemical reactions today. So here are some of the things that I need to be keeping on my mind actively as we're doing this. So what you do is first we take a couple minutes, have the students, write out their examples. And I want to make sure we can apply everything we're doing to not only a physical classroom environment, but to a virtual environment as well. And the way we could do that is, if we're in a virtual situation and, we can't write things out by hand on paper, we could write things out digitally. And then segueing to the next step, after we do our entry ticket, we're going to try to form, as best we can, a fishbowl discussion. Now, if we're in a classroom, what you can do is have your students turn into groups, discuss with the groups what they have wrote down as their examples of chemical reactions, and maybe someone wasn't able to write down 3 different examples, and they can be helped out by their teammates, and that's fantastic. So that way they can both help have a more secure knowledge base for this lesson. However, if we're in an entirely virtual environment, what we could do instead, we compile our lists on our own, and then we go into our groups virtually. And this can be done in the form of like a discussion thread. We write down our different examples and we try to support them, and we combine them with our group and we explain what we're going through, and we can write it out. All right, so we've looked at it individually, we've looked at it in a small group, and now we can take a look at it as a whole class type of idea. So when we have a whole class type of idea and we're in a classroom, I can go to group number 1 over here and I can say, what's an evidence that you had of a chemical reaction, and can you explain it to the class? They go and they explain it, and I go to group number 2, group number 3, however many groups we have, and every group has a chance to contribute to an overall class understanding. Now, in an entirely virtual environment, that can be a little different. So what we can do in an entirely virtual environment is we take the same theory of using a type of discussion thread where we can all work and contribute on it together. So each group can be responsible for maybe writing down 2 different evidences for a whole class list of evidences of chemical reactions, and they can try to explain it as best they can. And that gives them more repetition. We're trying to get ideas translated from their head onto some kind of format that someone else can interact with. And that's done handwriting or digital writing. So I think those are different ways that we could accomplish the same entry-level activity in both a physical and a virtual environment. And then we're going to be segueing from there into our introductory activity. Our introductory activity is going to be our main engagement in this lesson to try to get students, now that they're thinking about science a little bit, to see an example of it and be able to interact with it. So what we do is we take very common household things like lemon juice. Right here I have my little bottle of lemon juice. So what I do is, since I don't have a little container to pour it in, because I don't want to be wasteful, I just pour a little bit into the cap here, and I take my Q-tip and I dip a Q-tip into that lemon juice. It's on there now. Then what I do is I take a little index card, like you see here, and I draw on it. So I'm going to draw just a couple of lines. I got 3 little lines on there. Don't think you can see that very well, but you get the point of what I'm doing. We're taking lemon juice and we're drawing it onto index cards with a Q-tip, and that's fine. And sometimes it'll take a little while for the lemon juice to really dry into the index card. So a while ago, I made this other drawing. You can't see what it is because it's dried. It's invisible. What we're making is called invisible ink. And what we're doing is we're going to be looking at the evidence of a chemical reaction when we create invisible ink using lemon juice. So, the lemon juice is applied to the note card. You can't see what it is. Here's the one I just drew on. It's already starting to get pretty dry. Maybe you can see it just a little bit. And this note card, which I haven't wrote on at all yet, is completely blank. You cannot tell which is which. And that's the whole point that we're going for here. So now that we have our note card, it's dried. We can do this in the classroom or in a virtual environment. Just remember that whenever we are handling flammable things, or we're using something like an old light bulb that puts out a lot of heat, or something like a hair dryer, anytime we're handling hot things, we need to be very careful about what we're doing and follow proper laboratory safety procedures in the classroom or at home. You always got to follow proper safety guidelines. So what we do is we take our index card and we're going to expose it to the heat, and we're going to see what the heat does to this note card. So I hold it over this candle here. Oh, we're starting to get a reaction. All right, just a couple more seconds and we'll be good. All right, so I held it over the candle. You watched me the entire time I held it over the candle. And now this is what my index card looks like. We see a little smiley face on there. So that's great. That's exactly what we're going for here. So what happened was we took our Q-tip, dipped it in lemon juice, we drew on an index card, and then let it dry, and then when we heated it up, we could see a drawing appear. Now this one I drew a smiley face on. If you recall, earlier in the lesson when I drew on this example card, I just drew 3 little lines. The smiley face I drew a lot earlier, and I chose a different drawing for it. So, we've seen something invisible turn visible. Now, we start looking at what the main thing we're going to be working through today. These I call observation guides, or I might just refer to them as guides. And they're going to look a lot like this. And you'll have digital copies that you can look at and interact with so you can more clearly see what I'm talking about, but I'll be trying to say as much as I can about it out loud. So we're going to be filling this out for the reaction just so that students can be held accountable for not only experiencing something, but being able to relay back what they experienced and apply scientific knowledge to it. So we look at our first question on here. Describe the chemical reaction you just observed. Now, thinking about it in as simple of terms as I can, we took lemon juice, put it on a note card, we let it dry, and exposed it to heat, and at some point during the exposure to heat, the lemon juice reacted to reveal what was previously invisible. So describe the reaction that we just observed. Now it's a chemical reaction. Make sure that we know that that is a chemical reaction, largely because of how irreversible it is, and the fact that it fundamentally changes what's going on, chemically speaking, with the lemon juice. What observations can you make about this chemical reaction? Now we need at least 2 observations. I think observations are very, very important, and I want students to be able to not only just look at something and notice what they initially see, but I want them to look a little deeper, which is why I ask them to think of 2 observations here. So we take a look at our little drawing here. What do I observe about it? Well, I can clearly see the outline of where the lemon juice was. You can clearly see the outline of where the lemon juice was. And you can also clearly see that there was heat applied to it by the yellowing of the paper. And some of it got really yellowed and turned a little bit brown in different parts, which is good. So I do prefer to use note cards instead of standard printer paper for this experiment because note cards are a lot thicker and you want to absolutely minimize your chance of catching something on fire, which is why I use the index card so I can be safer about it. So, observations I can make. We just went over, we can see where the lemon juice was. We can tell the paper was exposed to heat. And what's something else we can notice about it? Let's think a little bit deeper. So, when we look at our note card, we can see that we could write something invisible in theory, let it dry, and be able to re-see it later. Now, this note card in particular, I wrote this message like 2 or 3 days ago. So this does work over the passage of time. So that's something definitely that we can keep in mind, and that's going to lead us right into our next question. What additional question or questions do you still have about the reaction as presented? And I say you need at least one question on this, and that way everyone can be held responsible for thinking at least a little bit deeper about what we're talking about here. So a question that I still have that I just started thinking about. So I've seen that you can reveal the message that you wrote invisibly after about 2 or 3 days. Now what about if we change the length of time drastically? Or what if we didn't have a length of time? What if I caked on a bunch of lemon juice and it was wet and you could see what the message is, and then I exposed it to heat? Would it still reveal quite the quality that this has? That would be a good experiment. So that'll lead us into our final question here, and our next question is going to apply to the engineering design process, because that's very important in education, that students can start thinking critically about ways they can modify something and what that kind of modification would yield as an effect in an experiment. So what are different ways you'd want to modify this experiment? What do you think the new result will be? Now you need at least 2 modifications. And I like having at least 2 modifications here because it really encourages students to think, well, here's what I want to change, and here's what I think it'll do. And I really like to push them a little bit on that because you can come up with some really brilliant ideas that way. So what are some different ways that we could modify this experiment? Well, one initial way I can think of is we can modify the amount of lemon juice added when we create our little invisible drawing, when it looks like this. If we added a lot more lemon juice, it would still be soaking wet right now, and you could see what the drawing is, and it'd take a much longer time to dry. So it taking a much longer time to dry would be a good effect as to what would happen if we'd add more lemon juice. However, another modification we can make is the one I was referring to earlier. What if we change the length of time that we let it dry? What would that change about the final drawing that we get revealed? Another modification we can make, what if we change the material? What if I didn't want to use lemon juice? What if I wanted to use grape juice? Well, if I use grape juice, my initial idea would be, maybe we would see a new result. Maybe we would still see a result. Maybe it would look a different color. Maybe, I don't know. But that's the whole point of it. We don't know, and that's why we're coming up with these ideas and we're making predictions based on evidence. My evidence is lemon juice reacted with the oxygen attached to the flame, but would grape juice? That would be an experiment we could perform, and that's the beauty of the engineering design process. We look at potential experiments that we could perform, and we could do them. So, the next stage of what we're doing, we're actually going to get into the body of our lesson here. And the main body of our lesson is going to involve a learning database called Legends of Learning. So I'm going to change what screen I'm on here. So now I'm just a little guy in the corner. Now, Legends of Learning is a database of science and math games for elementary and middle school. And the benefits of Legends of Learning are that it can really specifically target different skills you want your elementary or middle schoolers to be able to hone scientifically. Today we're going to be looking at chemical reactions, evidence of a reaction. However, we're not going to play this specific game up here. This is a great game, but this is not the game I chose to go along with this lesson. I chose to work on the React Lab. I really enjoy the React Lab. Now you will hear some music once we get it started and click Try Game. Now, this music can get a little repetitive after a while, but we're going to talk it through, and we're going to have a good time going through another one of these observation guides. So while we wait for the game to load, let's refresh ourselves on our observation guide and the keys that we're looking for. We're looking for describing the chemical reaction that we just witnessed. We're looking for observations we can make, we're looking for questions we still have, and we're looking for modifications that we can make to the experiment and predicting those new results. So, React Lab. In a chemical reaction, reactants rearrange the atoms, bonds are broken, atoms are rearranged, new bonds are formed, giving rise to products. And here we can see an example of a chemical equation on the bottom of the screen with our reactants in red, our products in green, and our little yield sign here in the middle in blue. So, products have different chemical and physical properties than the reactants that form them. Properties that can change include density, physical state, boiling point, melting point, solubility, flammability, color, and smell. Now, these are the exact same evidences of a chemical reaction that we listed in Standard 5, and then that's also going to go along with very, very closely to the ones that we got in our entry ticket activity. So keep that in mind, and we're going to see those again right here. The evidence that there was a reaction is seen through different signs in the products. So that's the right side of our chemical equation, such as a change in color, a change in temperature, the release of a gas, dissolution, the precipitation of solids, the separation of liquids, or change of odor. Now, these are different evidences that we are going to see in this React Lab. And remember, they always occur in the product side of a chemical equation. Dan is a little mouse who loves chemistry. Help him solve different riddles with the help of chemical reactions. Alright, so we're going to go to level 1 here. And we're going to play through 2 levels of this after we go through this introductory activity here, because you need to equip yourself to start the journey. So we need to be safe. We need to follow proper laboratory safety procedures. So things that we're going to need. In our reactants, we have boots, safety glasses, mask, gloves, lab coat. And those are going to yield equipped to start the journey. And that's a little chemical equation we have about proper laboratory safety. So now that we're all dressed up and we got all of our proper laboratory safety gear on, we can go to the exit. We can get into our first level here where we're looking at different chemicals. So this is the first of the 2 levels we're going to be going through. So the door is very cold and we need to melt it. Ethanol and oxygen react to generate heat. So things that we need, ethanol and oxygen. And those are going to react to yield carbon dioxide, water, and heat. So what we're looking for is our reactants. We need C2H5OH and 3 moles of O2. And in our products, those are going to yield heat. Heat is our main thing because we need to melt this ice door. So we grabbed our ethanol, we grabbed our oxygen gas, and we're going to take it over and we're going to react to them by clicking start. What do we produce? 2 moles of carbon dioxide, 3 moles of water, and a temperature increase. So our door is melting. Now, before we head over to our exit, let's think about what we just did in terms of our observation guide. Because the key to this lesson is students can complete 2 to 3 copies of this observation guide based on different reactions that they see in this React Lab. We go through one together with our introductory activity where we make our little smiley face or whatever drawing we want out of invisible ink. And that's sort of our way of saying, okay, here's the proper way we can go through this once. Now you're on your own to replicate it. So, describe the chemical reaction that you just observed. We combined ethanol and oxygen gas to form carbon dioxide. What all did we form? Carbon dioxide, water, and heat. Alright, so that's how we describe our reaction. Ethanol and oxygen reacted to form carbon dioxide, water, and a temperature increase in the form of heat. So that's how we describe it. Observations we can make. The heat caused the ice blocking the doorway to melt. That'd be a good observation. Now we need 2. So what's another observation we can make? We were able to produce carbon dioxide and water. Those are 2 very common compounds that we interact with. So that'd be a good observation we can make. We can also observe that this is an exothermic reaction because heat occurs in the products of our chemical equation. So what additional questions do we still have about the reaction as presented? We need at least one question. What would happen if we used a different gas instead of oxygen? What if we used nitrogen gas? Would we still be able to get a temperature increase as a result? That'd be a good question. So different ways that we can modify it using the engineering design process. So that would be where I like to try to answer one of my questions. That would be an initial reaction for me. So I try to answer what would happen if we use nitrogen gas instead of oxygen. I predict that it wouldn't bind, or it wouldn't bind in the same way. So that way we probably would not have a temperature increase. So my predicted result would be it would not bind in the same way that the oxygen bound with the carbon with the hydrogen to produce heat. Alright, so that's modification 1. Modification number 2, what if we replaced ethanol? What if we replaced ethanol with a totally different compound that had a different number of carbons, a different number of hydrogens? Well, what would that do to it? Well, maybe it wouldn't react. That'd be interesting. That'd be interesting. What if we perform this whole reaction under intense pressure? So the molecules wouldn't be able to move about as freely. That'd be interesting. That'd probably cause a no reaction if it's high enough pressure. So we've answered all of our questions on our guide. Now we can move on to question number 2, or level number 2, or level number 3. I think this is level number 3. So this one we're going to go through, and we're not going to go through our guide this time. I just want to enjoy going through this, and we can talk about other great things that are available on Legends of Learning. So the water is deep, we need to push the boat. A chemical reaction of sodium bicarbonate and hydrochloric acid generate carbon dioxide in the form of bubbles. Things that we need sodium bicarbonate, NaHCO3, and hydrochloric acid, HCl, and they're going to form sodium chloride, water, and carbon dioxide. Alright, so we have our sodium bicarbonate, we have our hydrochloric acid. Now let's go and react them. And we get CO2 in the form of a gas, and those are the bubbles that are going to make our boat go. We have salt and we have water. Alright, so let's go over here, let's hop on our boat, and we're going to cruise over here. Now, Legends of Learning is fantastic because it offers such a large database of different ways you can engage both your elementary and your middle school science and math students. So it's very cross-disciplinary in that sense. You can address both math concerns and science concerns using the same program, which I think is a really great tool. And these games are very oriented towards critical thinking. Now, I'm going to close out of this game so we don't have the music anymore, and we're going to change back to our original screen here so you can see me a lot better. Alright, there we go. So, once students have had an opportunity to complete 2 or 3 of these, then we get the chance for students to, turn and talk. Go share some of your ideas with another student and try to teach them one of the reactions that you wrote about that maybe they didn't, and have them fill out a sheet fill out another one of these observation guides based on what you told them. And that would be a great way for you to be able to teach the science that you're working with to someone else who's also on about that same level of understanding. And that's another great way that students can be evaluating each other, evaluating being the highest of Bloom's taxonomy, and it also being the last of the 5 E's. So, let's talk about how we've addressed our 5 E's in this lesson. We have engagement, where we perform our little activity here, where we make our invisible ink. We explore. When we're looking at the React Lab, we're looking at different ways we can solve chemical reactions. We're looking at different evidences, and we're trying them out, seeing how many different evidences we can come up with. So we have explain, where we look at the little introduction to the React Lab, where it talks about in detail the different types of evidences of a chemical reaction. We also explain when we have our entry ticket and discussion about it with our little fishbowl discussion. We elaborate when we start to fill out these observation guides, when we start to come up with different modifications that we can make, when we try to further what we know and what we can do. So we have engage, explore, explain, and elaborate covered. Now what about evaluate? We evaluate when we turn and talk. When we go to our other students and we say, here's what I've come up with, and they say, okay, here's what I think about what you've come up with. Here's what I think you can add to it. Or when you teach it to them. Students evaluating each other is the highest level of evaluation, and students having that opportunity for collaboration. Now, if they can't do it in a physical classroom, they can try to do it through discussion virtually. There's nothing we've done in our lesson that said you had to be in the classroom. And that is, I think, the best way we could accomplish this. So, after we've shared with each other what we have wrote down, after we have completed all of our observation guides, we have our opportunity for our exit ticket. Our exit ticket is also going to be our introduction to our next lesson. And that's going to be writing down 3 different evidences for a physical reaction. So we just finished covering our chemical reactions, and then we're going to go and cover our physical reactions. And this exit ticket is very good at getting students to think about, okay, so we've looked at our chemical reactions, and I know what those are. Are there other ways things can react that are physical that cannot be done chemically? And then write those down. You know, it's a good way to get your students trying to think critically additionally, and that's the goal here. Try to get students to not only think critically, but apply it in different ways. So I've covered the 5 E's. I've especially covered evaluating and engagement. Those were my 2 strongest. So I believe that has completed our lesson for today. Thank you.